Since the discovery of petroleum more than 75 years ago, the transportation of this vital natural source has always been a major problem because the population centers where oil is needed are located far away from fields where the greater part of oil production has been developed. Most of our oil is transported by ocean-going tankers and by pipelines. Since the first few miles of primitive pipeline were constructed in Pennsylvania 3/4 of a century ago, the great network of pipelines supplying the eastern United States and Canada from the mid-continent oil fields has grown to 130,000 miles of main line, carrying close to 4 million barrels of oil every day. One of the latest pipelines, and a most important one for Canada, is the recently completed Portland to Montreal Esso pipeline. Let us see why this new pipeline is so important. Crude oil from South America to the Montreal refineries has always been delivered by tanker over the long sea route around Cape Breton Island and up the St. Lawrence River. From the New England coast, that's a distance of 1,000 miles, 2,000 miles for a round trip. Formerly, such deliveries had to be made in summer and fall, for the St. Lawrence River is icebound during the winter months. By contrast, distance overland from Portland to Montreal is only 236 miles, and by pipeline, oil now flows every day in the year, not only assuring eastern Canada of a steady supply even in winter, but releasing valuable tankers for vitally needed service in other parts of the world. The construction of this pipeline broke every known record, for a veritable miracle was demanded by the crisis which arose when President Roosevelt diverted tankers to carry oil to Britain. The only question was, how fast can this pipeline be built? This was indeed a serious problem, for the pipeline had to traverse not only these gently rolling valleys and farmlands of the province of Quebec and those of Vermont, but also the steep, rugged gorges of New Hampshire's White Mountains and the tough granite ridges of Maine. To survey these pleasant valleys and fairly level farmlands and this open countryside of Quebec was not an extraordinary problem. But to have surveyed the entire pipeline route by ordinary methods would have taken scores of skilled surveyors, a period of many months, precious time, which in the face of the emergency simply could not be wasted. For this reason, the route for the pipeline through this rugged region was first surveyed by plane, taking pictures from a height of 17,000 feet. By stereoscopic study of these photographs, the pipeline engineers could determine the exact contours of the valleys and mountains and so select the proper route. Mount Washington, raising its lofty peak over 6,000 feet and already snow-capped in early October, had to be avoided. By following its northern flank, the highest point of the pipeline was kept down to an altitude of less than 2,000 feet. As the job is started, work gets underway at emergency speed. These treaded juggernauts smashing their way into the forests are not tanks, but bulldozers, advanced scouts of the mighty mechanized construction division of the oil industry. Opening a 35-foot right-of-way for the other mechanized units which will follow them, they push over big trees, seemingly almost without effort, a thrilling demonstration of surging power. Think what an army of axemen it would take to replace these big diesel-propelled tractors, two of which can clear a mile a day of forest and bushland. Working in emergency time, these hard-hitting bulldozers are a fighting challenge to Hitler's panzer divisions of destruction, for they are adding another cog to the wheels of Canada's ever-growing war machine. No time can be lost in opening the paths for the pipes that will bring precious crude oil to our vast refineries at Montreal East. Great boulders that once would have taken hours of hard labor to move by horses and manpower are pushed out of the way like pebbles. When trees have been felled and boulders removed, stumps and undergrowth are quickly pushed out of the way. Stubborn stumps and roots are tackled time and again until they give way, for these powerful peacetime tanks never take no for an answer. After clearing, the ground is roughly leveled off by the bulldozers to make a passable roadway for other equipment to follow. Here again, tractors are at work, this time rolling across open farmlands. Streams, ditches, and natural obstructions mean nothing to them. These two tractors are working in tandem, using the combined power of both to pull an immense plow called a rooter. This rooter, weighing 6 tons, with a plow the size of a man, opens up a deep furrow to clear the ground of boulders and roots. Here they come from across the valley up a steep mountainside, plowing out the innumerable boulders which we find in the highly glaciated formation of Quebec and New England. Yes, it's a mighty tough job to open a trench through this country all the way from the Atlantic seaboard to the banks of the St. Lawrence River. Expert builders as they are, with experience in pipeline construction all over the world, the contractors had to admit that this was one of their toughest jobs. This gigantic plow leaves its furrow through valleys and over mountains as far as the eye can see. Following the rooter comes a strange-looking machine which deepens and widens the furrow into a sharply defined 4-foot trench. This continuous bucket ditcher excavates at the rate of 1.5 miles a day in ordinary ground, where the rooters have removed the boulders and debris of vegetation, depositing the soil in a neat mound alongside the trench. Where the soil contains many boulders and roots, a gasoline shovel replaces the bucket ditcher. The pipeline contractor must have at his command the proper machine for every possible type of terrain that may be encountered. Much of the line, however, passes through solid rock, which must be drilled and blasted. Scores of jackhammers, portable compressors, and tons of dynamite are needed to open up these rock cuts. Explosives used for peaceful and useful work. The line follows the topography of the terrain, and unlike a railroad, when a deep ravine is encountered, no bridges are built, but it simply goes down to the bottom and up again. Trainloads of pipe are unloaded and piled up at railroad sidings for transportation by trucks to the pipeline right-of-way. Almost 35,000 tons of this 12-inch seamless steel pipe are required for the whole project. To produce this quantity, a big Pennsylvania steel mill was kept busy for 2 entire months. Each pipe, 40 feet long, with walls 3/8 of an inch thick, weighs a full ton, 2,000 pounds. When the pipe has been delivered to the site, it is strung along the trench by powerful tractors equipped with side booms. These tractors are known to the pipeliners as boom cats. Years ago, pipe laying was a slow and arduous task, and dozens of men had to wrestle with these huge lengths to set them in place. In those days, it would have taken many, many months to achieve completion of such a difficult job as this. Now, with modern machinery, as much as 2 miles per day can be laid by a single crew. You will notice that in order to conform to the contours of the terrain, the pipe must frequently be bent to follow the rise or fall of the trench. Bending the pipe is another important job performed by the boom cats, usually working in pairs. While one of them holds down the pipe with its own weight, the other hoists the end of the pipe to make the bend. This bend, as we can see, is a very short one. When a long bend is required, the pipe may be hoisted in the middle, as we see here. This seamless steel pipe is so flexible that it may be bent cold. All this work is directed by foremen long experienced in pipeline construction. Up and down this narrow zone of activity go lean, high-booted gentlemen who talk the drawled lingo of faraway Oklahoma and Texas, giving orders to locally employed labor, to construction gangs, or to Texan lads driving the bulldozers and other machines employed in rushing this pipeline through in emergency time. During the first 40 years of petroleum pipeline construction, the pipes were assembled by threading them together with collars, or by bolting them together with flanges. Such pipelines were slow and costly to build, and there was frequently danger of leakage. The advent of welding changed all that. The pipes are first clamped tightly in place, and are then spot welded by an electric arc produced by power from a portable gas-electric generator. The clamp is then removed, and several beads of metal are applied by those modern visored knights, the expert welders. This results in a perfect solid welded joint which is as strong as, or even stronger than, the pipe itself. After welding, we therefore have a continuous tube of steel, such as we see here coming down Mount Sutton, one of the highest mountains of Quebec's eastern townships. This is part of the last range of mountains which the pipeline must cross before reaching the St. Lawrence Valley. The numerous bends in the pipe, which are necessary to follow the rugged topography of this mountainous country, also add flexibility to the line and serve as expansion joints when the pipe contracts during our cold winter season or expands during the hot summer months. Here the welded pipe lies on crossbars above the trench, awaiting testing before being lowered to its final position. Openings are left in the line at intervals about a mile apart, and before being tested for leaks, these sections of pipe are first cleaned by passing through them this scraping device, which the pipeliners refer to as the go devil, or the pig. Forced through the pipe by compressed air, the scraper pushes out all the dirt which may have collected in the line. Once the scraper is out, both ends of the pipe are tightly sealed, and the air pressure in the pipe is raised by means of a portable air compressor until it reaches a pressure of about 100 pounds to the square inch. Faulty welding may then easily be detected by smearing each joint with soap suds and looking for bubbles which would indicate the presence of a leak. To lower the pipe to its final position at the bottom of the ditch, tractors are again used to lift the pipe to enable workmen to remove the crossbars which hold it above the trench. This operation is carefully watched by an inspector who makes sure that stones or boulders which have fallen into the ditch are all removed so that the pipe will rest flat upon the bottom of the trench. Variations in temperature cause contraction or expansion of the line, which sometimes necessitates forcing the pipe down to take its proper position. This is accomplished by using the weight of a tractor, which rides on the pipe and holds it down, while part of the trench is backfilled. This great modern conveyor of crude oil is buried under 2 or 3 feet of ground, not only to protect it against the chills of the northern winds, but also in agricultural sections to allow the farmers continued use of the fields under which it passes. For this reason also, the large boulders are piled up out of the way by the bulldozers so that the farmers' fields will be cleared. In fact, hardly a trace of the pipeline will be seen after it is buried and the fields are again plowed and cultivated. Today, the little community of High Water on the borderline between Quebec and Vermont is the scene of an historic event, for here is being woven another of the many strands of friendship which have bound Canada and the United States together since the outbreak of the war. Symbolizing the united effort of our two great democracies, the Canadian and American sections of the pipeline are joined together on the international border. Officials from both countries celebrate together one further success in the solution of our common problems, visible and inspiring proof that our democratic processes are able to bring about swift changes as well as efficient results. In a simple ceremony, the two sections of the pipeline are welded together by Governor Wills of Vermont, Honorable C.D. Howe, Minister of Munitions and Supplies, and the Honorable Adélard Godbout, Premier of Quebec. Mr. W.S. Farish, President of the Standard Oil Company, says that the pipeline is primarily a war effort to help Britain. Premier Godbout says it is a proof of good neighborliness. Honorable C.D. Howe stresses Canada's contribution to the North Atlantic Service, and Governor Wills of Vermont adds a few words of friendliness. It's hands of friendship across the border and thumbs up for victory. Representing our international friendship, a Canadian mounted police and a Vermont state trooper stand side by side beneath the flags of our great democracies. Continuing northward toward Montreal, the pipeline must cross two rivers. First, the Richelieu River, 1,200 feet wide at this point. To lay the pipe beneath the waters of the river, it is first welded together on land in 600-foot lengths, such as we see here. It is then dragged to the shore and fastened to a barge which holds its forward end out of the water. The end which remains upon land is pushed by a powerful tractor which moves the pipe forward, sliding it along like a monster serpent across the muddy clay of the Richelieu Valley. The pipe is coated with special asphaltic enamel to protect the steel against corrosion when it is laid under the water. The head of the pipe fastened to the barge pushes it slowly across the river. Two 10-inch pipes are laid side by side across the river, joined by manifolds on both banks to the single 12-inch pipe on land. While the barge is pushed across the river, a tug in midstream holds it against the current. The second river which the pipeline must cross is the Great St. Lawrence River, which at this point is some 13,000 feet wide, including 3 islands and 6,000 feet of main channel. Since the pipe has to be entrenched in the river bed, a sounding and marking dredge is first used, followed by drilling and blasting equipment. Then this powerful bucket dredge digs a trench in the bed of the river, a trench 20 feet deep and about 30 feet wide, requiring the removal of countless thousands of cubic yards of mud and rock. Here we see the barges used for the actual laying of the pipe across the river. This part of the pipeline job also was completed in record-breaking time. Here again, as in the crossing of the Richelieu River, two 10-inch pipes are used, in this case, both lines being laid in the river simultaneously. From an assembly barge, where the pipe has first been welded into 150-foot lengths, it is raised to the long inclined scaffoldings of a rigging barge, where it is deposited and aligned by the crew for lowering into the river. This 10-inch pipe is extra heavy, with a wall thickness of ½ an inch and a weight of 54 pounds to the foot. As soon as these pipes are aligned on the scaffold, they are welded to the ends of the lines which have already been partly lowered into the river. After the joints have been electrically welded, a heavy steel sleeve is slid over the joint and welded to the pipe to give it greater strength and an added factor of safety against possible leakage. To prevent corrosion, the sleeve is then covered with the same special asphaltic enamel as that used on the pipe itself. Crossing the navigable channel presented difficulties due to the movement of ships which had to be diverted ahead of the laying barge. Thanks to the harbor authorities, however, no trouble was encountered. 6 anchors like this one retained the barges in proper alignment against the swift current of the St. Lawrence. Heavy cables tie these anchors to the barges, and buoys on the surface indicate where the anchors lie at the bottom of the river. As operations progress and the barges move forward, the location of the anchors must frequently be changed. At every joint, 500-pound weights attached in pairs to spacing bars are bolted to the twin pipes to hold them down at the bottom of the trench in the river bed. The spacing bars keep the two pipes parallel. As each length of pipe is joined and the weights attached, the barge is slowly advanced, allowing the completed section of pipe to slide down the inclined scaffoldings into the river. Care must be taken to align the pipe so that it will slide down into the deep trench previously dredged in the bed of the river. Pontoons strung up behind the barge prevent the pipe from bending too sharply while being lowered. Meanwhile, on both shores of the river, manifolds are set up to join the twin 10-inch pipe used under the river to the 12-inch pipe used over land. From time to time, the inside surfaces of these pipes will require cleaning, and for this purpose, complicated sets of valves are so arranged that scrapers may be inserted into the pipe to be pushed through the line by the flow of the oil itself. To push the oil through the 236-mile pipeline from Portland to Montreal, 8 powerful pumping stations are needed. These are spaced at an average distance of about 30 miles apart along the line, and are all under construction while the line itself is being built. The first of these pumping stations is being constructed at South Portland, a few miles from the harbor terminal, where tankers will discharge their cargoes of oil into 6 giant welded tanks, each holding 140,000 barrels, a total storage capacity of over 33 million gallons of oil. To be ready for operation when the pipeline itself is completed, the pumping stations must also be built in emergency time, in spite of the great difficulty of obtaining materials and labor and the necessary pumping machinery. Inside the pump house, concrete foundations are installed to support 2 heavy-duty, gear-driven reciprocating pumps. Gas-tight walls of brick and tile will separate the pumps themselves from the big 500-horsepower electric motors, which will supply the driving power. Typical of the other stations along the line is this one under construction at North Waterford, Maine. Each of these intermediate stations has a 40,000-barrel surge tank to provide flexibility in the pumping operation. Here at Lancaster, near Mount Washington, is the highest station on the line. And here is the one at high water, right on the international border. At high water, there's not available sufficient electric power to operate the heavy motors that would be needed. Consequently, the station must produce its own pumping power from huge diesel engines, which we see here being installed by expert machinists. Since all these stations are located in more or less isolated sections, comfortable living quarters must be erected to house the station operators and their families. On November 4th, 1941, the first tanker carrying South American crude oil for the new pipeline arrived at Portland Harbor. The terminal dock at South Portland can unload 2 tankers at a time, and dredging of the harbor bottom during construction makes it possible to accommodate the largest ocean-going tankers even at low tide. As the first step on its historic trip to far-off Montreal, the oil is first pumped from the ship through these big flexible 12-inch connecting hoses. Surging through the valves and manifolds on the dock at the surprising rate of close to 200,000 gallons an hour, the oil flows through the big lines which connect the harbor terminal to the storage tank farm 4 miles away. Regular movement of oil to Montreal began here at the South Portland pumping station on November 10th, a full month ahead of the schedule originally planned. These great electric motors transmitting their surging power to the pumps start the precious crude oil on its epoch-making journey under a driving pressure of 450 pounds to the square inch. A journey which will never stop, for hour after hour, day after day, month after month. The steady, relentless force of the pumps will drive the precious cargo of the pipeline under the fields and valleys, over the mountains and under the rivers, in never-ending flow, to supply the life-giving arteries of Canada's ever-growing industrial machine. Over 50,000 barrels a day are counted off by the pumps with the rhythmic regularity of time itself. Flowing at a rate of a little over 3 miles an hour, it takes the oil almost 8 hours to move from Portland to the next pumping station at Raymond. Here another set of pumps shoulder the burden as the oil moves steadily on toward the North Waterford station. Climbing steadily upward into the White Mountains of New Hampshire, the oil begins to fill the surge tank at Gorham. Here again, great electric motors start to whirl, pushing the oil over the high flank of Mount Washington to Lancaster. Hour after hour, day and night, it moves toward its destination as each station in turn receives the oil and relays it along the line. After 2 days of steady flow, the oil reaches the international border at high water, Quebec. Here at the pumping station on Canadian soil, diesel engines instead of electric motors supply the power for the pumps. These diesel engines are designed to operate on crude oil, obtained directly from the pipeline itself. So here the oil from the line literally furnishes its own power. These pumps are not required to work under as high mountainous regions. To send the oil on its way again through the gently rolling country of Quebec's eastern townships, a pressure of only 350 pounds per square inch is needed. Last of the 8 pumping stations on the line. Here the oil starts on the last lap of its long journey to Montreal. across the flat farmlands and through the twin 10-inch lines under the St. Lawrence River to these manifolds, where it is routed to the various refineries of Montreal East. On Sunday, November 16, 1941, at 23 minutes past 4 in the afternoon, the first drop of oil arrived here at the Montreal terminal, where its arrival was hailed by directors, engineers, and workmen assembled for the occasion. An occasion simple and unspectacular in itself, but momentous in its epic significance to the petroleum industry of eastern Canada. No longer must these great refineries of Montreal East depend on the longer, slower transportation of oil by tanker, as they have done for the past quarter of a century. No longer must they fill their storage tanks in summer to enable them to operate in winter when the mighty St. Lawrence River is icebound. Today, and in the future, assured of a steady flow of crude oil brought by pipeline every day in the year, these refineries may plan their operations for greater efficiency and service to the people of Canada. The Portland to Montreal pipeline gives us greater assurance of receiving all the petroleum products that our modern civilization and the emergency of the hour demand. Oil to heat our homes, our buildings, and our factories. Oil for transportation. Oil to power and lubricate our industries. Oil for war, to move our tanks, propel our ships, and fly our planes. Oil on its way to speed the victory, which means the preservation of our freedom and our great democracy.